corn seeding rates for Western North Dakota. I also want to quickly take a moment and put out a big thank you to Kayla Elis. She's my master's student. She's from the New England area, and she's been doing a tremendous amount of work the past 2 years with the field side of this project and also the data processing. And she'll be graduating in May of 26. So thank you, Kayla, for all your hard work and helping us refine seeding rates for Western North Dakota. So it's well established that corn yield is optimized at lower populations in drier environments compared to wetter environments. That's quite well established. Eastern North Dakota has pretty well established guidelines for corn. Typically, we're seeding 29,000 to 35,000 seeds per acre with a target established plant population in the 28 to 34,000 plants per acre neighborhood. However, we lack robust data on appropriate corn seeding rates in Western North Dakota, at least within NDSU and our REC system. That just hasn't been a focus traditionally, but as corn acres have really expanded west and now also moving north as well, we thought it was time to revisit this. The current published guideline is 16,000 to 25,000 plants per acre for a population, but this is quite a wide range, and certainly my hypothesis is that we have the ability to dial that in a little bit better for Western North Dakota. And something to keep in mind is that the interaction between corn population and crop water use is fairly complex. So yes, as plant population increases, the corn crop is using more water in general. And there is a point at which intra-species competition, or that corn-to-corn plant competition, for limited water will limit the yield of that crop. However, there's also a lot of other environmental factors that are changing in the field as we manipulate population. So for example, at higher populations, we have a denser leaf canopy, which shades the soil and cools the soil surface, and that can reduce evaporation. Wind movement in the canopy is also reduced, especially at our higher population densities, which again reduces evaporation. It can increase humidity, and that would reduce transpiration of the water loss from that corn crop as it's using water. And also, higher populations shade neighboring plants more than at lower populations, so that can also keep leaves cooler and reduce transpiration. So there's a lot of things happening in the field is the take-home message for that as we manipulate population. And then sort of a secondary hypothesis of this work is we wanted to dig in a little bit to fixed versus flex ear types. Many corn companies and corn hybrids available now are marketed as either a fixed or a flex ear type, and we wanted to know if ear type would be a factor in the consideration for seeding rate decisions, especially in Western North Dakota. And so for those of you unfamiliar with the idea of a fixed versus flex ear type, simply a fixed ear hybrid is one that's expected to maintain its cob size regardless of population density. And so the traditional assumption is that with a fixed ear type, the more plants you have out there, the more cobs. If they're all the same size, more cobs, more yield. So fixed hybrids are typically maximizing your yield in wetter environments with higher population densities. But then when water is a limiting factor, perhaps a flex ear type may do more to support yield. So flex ear types are those genotypes that have been determined to flex or change their cob size in response to population density. So we expect that flex ear hybrids would make a bigger cob with more kernels at lower population densities, and that might be able to compensate for fewer cobs because you have more kernels on each cob. But again, there's not a lot of published data out there really looking at that, and even less data looking at it in dry environments. So we wanted to put that to the test in Western North Dakota. And just for a visual, this is a drone image taken in Hettinger in 2025, just an overhead view of our plots. And to give you a sense of those environmental changes that happen with manipulating crop density, you can see that we have a 10,000 seeds per acre seeding rate in the middle, right next door to a 38,000 seed per acre seeding rate. So almost 4 times as many seeds went in the ground, and established population almost 4 times as high. And now granted, this picture was taken pretty early season, I think at about V5 V5, V6, so clearly we don't have canopy closure yet, but you can imagine just that difference in density affecting things like how much sunlight's hitting the soil surface, how much water is evaporating from the soil, how much shade those corn plants are throwing on one another or not. So again, when we change population, we're manipulating all those parts of the microclimate of the crop. So just to remind everybody, with our precipitation gradient in North Dakota, it's pretty severe. We have drier conditions in the west compared to the east. And again, historically, our corn growing area has really been southeast North Dakota. But over the past 20 and especially the past 10, 15 years, we've seen corn acreage expand west and also north. For now, the seeding recommendations that I'll be presenting are really focused on sort of the southwest quadrant of North Dakota. I will be interested in the future to perhaps replicate some of this work in the northern tier. Certainly, there may be a little bit of difference when we get into some of our very short season varieties, things like 70, 75-day corn. You'll see varieties used in this trial were in the 76 to, I believe, 84-day range, so a little bit more appropriate for the southern tier, but also southwest quadrant of the state. But again, sort of the unifying factor of this area is that lower precipitation regime compared to the east. So in 2024 and 2025, we had locations at the USDA ARS facility in Mandan, and then also at the Hettinger Research Extension Center. And then in 2025, we added a third site at the Dickinson Research Extension Center. So these are the physical locations where we did these experiments. So looking at the factors that we tested, I already mentioned in 24 we had 2 sites. In 25 we thought we wanted to get a little bit better coverage of the west, so we included Dickinson. For seeding rates, in 24, the first year of the experiment, we had 5 different seeding rates: 10,000, 14,000, 18,000, 22, and 26,000 seeds per acre. But based on the data that you'll see, we felt like we didn't quite top out the population and get the corn to a point where there was too much intra-species competition and seeing yield fall off at the high end of the range like we expected. So to try to get that to happen, we increased our seeding rates in 2025, and we did 8 seeding rates ranging from a low of 10,000 seeds per acre to a high of 38,000 seeds per acre, increasing in 4,000 increments. And hybrids, we were able to keep our hybrids used in the project consistent between both years. We had 2 companies represented, Channel and Proseed, and then we had 4 flex ear and 4 fixed ear types from both companies. And then we also tried to get sort of a pairing of flex and fixed ears from each company at about the same relative maturity as much as possible. So again, our Proseed varieties, we had a shortest maturity of a 74-day up to an 86-day, and then in Channel, we had a short 79 flex up to an 86-day fixed type as well. And so again, these were a lot of plots at each location. We had 8 of those hybrids at those 5 or those 8 seeding rates, and then times 4 with 4 replications. So a lot of plots. Kayla did a lot of work. For some precipitation data, I thought this was necessary to kind of help set the table for the data that we're about to see. 2024 was a much drier year than 2025, and in fact 2025 was a particularly wet year at most of the locations. So as we go through the data, in 2024 in Mandan, we had a growing season total from April to September of 12.3 inches. At Hettinger, only 8.8 inches, so some pretty prominent drought stress, I would say, at Hettinger in 24. Certainly not as severe as 2020, 2021, 2022, as many places in the far southwest experienced in those years. But I would consider 24 a bit more representative of growing conditions generally in southwest North Dakota, whereas in 2025, we had a particularly wet May across central and western North Dakota, and then you can see there were also some fairly high rain totals in July and also at August at some of the sites there. So we did have about 40% more water at Mandan in 25 compared to 24, and Hettinger had 85% more precipitation in 25 than 24. And Dickinson was the wettest site, but we only have data for 25 from that year. So, thinking about the results, these are from Mandan in 2024. So, I would consider this kind of a typical year for Southwest North Dakota. Better for Mandan in terms of growing season precip than Hettinger. And what you're looking at here is yield on the y-axis, our seeding rate in 1,000 seeds per acre down on the X. And then the blue bar is all those fixed ear types grouped together. And then the orange bar are the flexed ear types grouped together. And so you'll notice that we had statistically similar yields between our highest, our 26 and our 22,000 rates, and then dropping down at those lower rates. In regards to the fixed versus flex ear type, we didn't see as strong a trend there as I was expecting. There is from some sites, I'd say some evidence, and if you can see my cursor, the orange bar, so the flex ear types, did seem to maintain yield a little bit better at lower populations relative to the fixed ear types. And then something that happened at quite a few sites is that our highest yielding treatment overall was a flex ear type at a high seeding rate as opposed to a fixed ear type at a high seeding rate like we expected. So I don't really have an explanation of that. We'll need to do more analysis, look at this at the individual hybrids, and draw some conclusion using that subset of data. But for now, looking at Mandan, it looks like we had similar yields between 22 and 26,000 seeds per acre in 2024, so we did not see a yield advantage to that higher seeding rate. Kayla also did a lot of cob measurements, again, to support the question, or sorry, the answer to the question that we're going to be asking about flex versus fixed ear types and how they may or may not be changing in response to the different populations that they're planted at. She took photos of all of our treatments. So what you're looking at here is the channel 180-24VT2 variety, which was a fixed ear. And this fixed ear type did have the highest yield at Mandan in 24 of 145 bushels per acre at the high seeding rate of 26,000. And so I'll just have you note that with this fixed ear type, fairly consistent cob size from the high of 26,000 all the way down to a low of 10,000. So that was a little unexpected. I would say you can see, more tip fill, kernels at the very end of the cob being filled out at the low seeding rate as opposed to the high. Sometimes a rule of thumb you hear from more easterly corn growing states such as Iowa, Illinois, is that if you do not have about a half an inch of tip dieback or no kernel fill at the tip, then you're probably not maximizing yield. But again, in places like Iowa and Illinois, where rainfall is typically 30 to 40 inches per year, as opposed to us here in North Dakota, where we're 20 to 24 in the east and as low as 14 to 18 in the west. I'm not quite sure that rule applies, but at least at this location in this year, we did see these smaller cobs, but more of them, maximizing yield at Mandan. So to compare that with Hettinger, so Hettinger had a lot more drought stress. Again, it received less than 9 inches of precipitation during the growing season. And what you can see is we had, again, statistically significant yields, 70 and 69 bushel per acre at the 26 and 22,000 seeding rates. So we did not gain yield with the higher rate. Yield did step down at those lower seeding rates. And then thinking, what did the fixed and the flex ear types do? Again, I don't have a good explanation for it. We still have to take the time and analyze the data by hybrid. But we did see the fixed ear types generally out yielding the flexier types, though not significantly, at Hettinger in 2024. And again, the expectation was that these flexier types would be maintaining yield at the lower populations better than the fixed, but we did not consistently see that. And also, I would say comparison of the drought stress, our yields at Hettinger in 24 ranged from about 50 bushels per acre up to about a high of 80, whereas at Mandan, the range was about 60 bushels up to about 160 bushels. So having that additional 4 inches of rain really made a difference. For Hettinger in 24, the highest yielding treatment we had was this Proseed 1984, which was a flexier type planted at 22,000 seeds per acre. And now again, just to look at these cobs from the different seeding rates, 10,000 is on the left, 26,000 is on the right. Again, there's better tip fill at the lower populations, which one would expect. Overall cob size, I'd say the jury's still out. Kayla is going to be measuring kernel weight and kernel number from every cob that we subsampled from the plot. So we'll have a nice data set to dig into this a little more. But for now, I'd just say we didn't see obvious visual differences in most cases for most of our varieties in terms of these cobs either being a fixed type or a flex type. But we have more data to go through to figure that out. Moving on to 2025, so a much wetter year. This is data from Mandan. Again, our highest yielding site. And I'm sorry, my little banner is blocking my view here, but I believe it says no frost or freeze damage. That'll be something we'll talk a little bit about here with the 2025 season. We had statistically similar yields at the high rates of 34 and 38,000. Again, because we didn't see yield dropping off at the very high rate like we expected to, we increased the number of seeding rates we had in the second year of the project. I will say I was really surprised that we did not see an overall drop in yields at 34 or 38,000 plants per acre in 25 at any of our locations. I was really expecting, especially the last and maybe the last two, to really decrease yields again because of too much corn-to-corn competition for limited moisture. But in 2025, it was a very wet year, and so clearly moisture was not a limiting factor here at Mandan. Again, fixed versus flex. Seeing a little bit maybe of the flexier type not decreasing as steeply at the lower seeding rates as the fixed, but regardless, not really a strong trend there. And again, yields ranging at Mandan from about 90 bushel to over 180, which is quite good for Western North Dakota. All right, and I see Jeff turned on his camera, so I will keep rolling here. In Dickinson, so something to know about Dickinson and Hettinger, those sites did experience frost or freeze damage that first week of September, like many of our producers did across the state. Dickinson just had light frost damage, but we do believe that it did negatively impact the trial. None of the maturities that we were growing were at black layer at the time of the frost. But despite that, so we do think that the frost did not allow us to see the trends we were expecting. However, it is interesting to note that we saw statistically similar yields from that 22,000 seeding rate all the way up to the 38, and then again yield stepping back at those very low seeding rates. With Hettinger, we had pretty severe freeze damage. That early September freeze killed the plots. Temperatures got down to 28, 29 degrees before maturity, and yields ranged from about 90 to 108 at the Hettinger site. However, there were no statistically significant differences between any of the populations detected, and so I think that the in this case, freeze damage was definitely the overriding factor compared to the population. And then to kind of wrap this up, and something I'm very excited for Kayla to dig into as she transitions from fieldwork to writing her thesis, is what does this mean economically? So thinking about the cost of a corn seeding rate, thinking about Hettinger in 2024, the cost difference between seeding 26,000 and 22,000 seeds per acre, assuming a $240 cost for an 80,000 kernel bag of corn, you'll be saving $12 an acre at this lower rate. Again, we did not see a statistically different yield. So a revenue with only one bushel difference, $4, seed cost difference of $12. Not only a higher partial return per acre for that lower seeding rate, but also I think a big one for folks in Western North Dakota to think about is that seed savings when you're multiplying $12 an acre over however many acres of corn you're growing. So just in the example here, 160 acre quarter section, you'd be saving $1,920 with that seed cost savings. And then if you're also bringing in an additional $8 per acre higher return, yes, of course, partial return, another $1,280. And so it's really like a $3,000 swing, taking into account both the seed cost and yield difference or lack thereof. And so preliminary conclusions, we didn't observe a yield advantage for 26,000 versus 22,000 seeds per acre. So I think that top end for Western North Dakota, we might dial back a little bit from 25,000, the current rate, to somewhere in the 22,000 neighborhood. So far, we haven't observed a consistent pattern of yield being increased with either a fixed-year type at higher population or flex-year types maintaining yield better at lower populations, but we're going to dig into that more. Getting corn to black layer is very important, certainly not earth-shattering news, but I think it is pretty eye-opening just to see that a frost or hard freeze damage can override even very large population differences. And as I mentioned, Kayla will be working to dig into that cob level data as we move forward. So thank you very much for your attention, and I'm happy to take any questions.